Isn't it lovely to take some time as an opportunity to reflect on pedagogy and on those things that are so important to us and so important to our schools and so much our core purpose? I reflected that it was, again, as with Dylan, a refreshingly positive response to the challenges that we feel that we're facing with policy when we described that we were feeling maddened. And we know what's right, but we seem to be in conflict with policy, and maybe what Guy has just talked about and what Dylan talked about is our response, is our call to action that Sue set the challenge earlier on the stage. Both Dylan and Guy have talked a lot to us, really, about our role in ensuring students know what to do when we don't know what to do. And there was a very clear message from Guy that actually we can use content as the exercise machine for developing attitudes to knowledge and of knowledge. We know about intelligence. I like the way you described as friends the vocabulary around the dispositions that we know our learners need and want. But our challenge really is, how do we make that the bone marrow of everything that we try to achieve in our schools? How do we create environments that are tolerant of risk and where we're all excited by adventure? So both Dylan and Guy, I'd like to thank you for giving us so much food for thought. And both Guy and Dylan, of course, are going to be lead academics on the Redesigning Schooling programme. And certainly what you said today has given us a lot to think about. So I'd like to thank Professor Guy Claxton. Now, I wonder whether our next speaker may need an introduction. We became aware of Professor Eric Mazur's work in the United States a few years back. We were looking at effective methods with co-construction that really were making a difference to promoting whole brain thinking, higher level questioning. And his work was linked to utilising new technologies as a way to do this, and was cited as an example of genuine co-construction through technology. However, when we started to explore this in more detail, we got more excited because we realised that actually the technology wasn't the driver at all. The driving factor was this ethos, this passionate belief in the power of co-construction to enhance learning. And put simply, Professor Mazur's approach is effective pedagogy. And he's found some exciting ways of enhancing engagement through that. Since then, we've followed Eric's work with excitement, and we were absolutely delighted when he accepted our invitation to come to talk to conference this year. Colleagues, I'd like to welcome Professor Mazur from Boston, Massachusetts.
Thank you. Well, it's time to get some interaction going. That's the problem with these learning spaces, or these spaces in general. The audience is put in a passive role, so I hope to actually engage you all, get you doing something. In fact, in my workshop, I'm going to show some data, some absolutely mind-blowing data that were collected at MIT that showed that people in an auditorium, including students in the classroom, have less brain activity when they're sitting in an auditorium than when they're sleeping in their bed. And I think that, you know, we need to get things going. Well, a number of you have already registered on the Learning Catalytics website. I see the number going up rapidly here. That's good. But if you haven't, point your browser at lcatalytics.com or Learning Catalytics. You can spell it out in full if you want, on any web-compatible device. And then, if you still need to do this, it's going to take you a few minutes, but I won't just wait. I'll keep going. Create a free student account using the sign-up code DEMO, and then join the session 1, 2, 3, 4, 5, 6, 7. So I hope that as many as possible can join. Otherwise, you know, share a device, because some of the things are not going to be projected; they're going to be on the devices. So I think the media, politicians, they all want to make us believe that it's the economy and employment that is the most important problem in the world. But I think that in here we all agree It's neither of those. It's education. And we're here to find ways to improve education. But it's very difficult to have a meaningful discussion about education without first having really defined what education is. So I want to start by having you think a little bit about education. I mean, if I were to give you a little exercise and ask you to pull out a little piece of paper and write down a concise definition of the word education, I think many of you would be struggling, including myself. I mean, we all know what we mean by education, but to actually articulate it is not that clear, which is kind of odd, right? Because we're in the industry of education, so we ought to know what education is. Okay, so in order to get a better idea of what we really want to accomplish, I want to start with a little exercise where I make you think about your own education. So pull out a little piece of paper, or if you have a device in front of you, you can use that device. And I want you to think about something you won't have to reveal that, so you can be brutally honest, about something you are really, really good at, something you're proud of, right? Because in general, the things you're good at, you're proud of. And I want you to write that down. It could be doing mathematics. It could be public speaking. It could be dealing with youngsters. It could be baking cakes. It could be gardening. Ideally, I want that something to be a skill or knowledge that has advanced you in your career. And if you haven't made an account yet, the instructions are still at the bottom. Point your browser there. Create a student account using the sign-up code demo, and then join this session. Now, you know, when you're good at something, you can usually feel it. Other people respect you for it. And as soon as you've committed that to paper, or to mine, that's okay too, fold it up. You don't have to reveal it. You won't have to show it to your neighbor. It's completely private information. Does anybody need more time? Oh, God, you're way too silent here. Okay, we're going to change that, I promise you. As soon as you've committed to something, I want you to think about how you became good at whatever it is that you wrote down. Where did you learn that skill? What were the circumstances that led you to develop this skill or learn that knowledge? Write down in a few words, using your handheld device, the circumstances or activities that led you to develop that skill. Okay? I won't be able to project this, so you'll have to look over the shoulder of somebody who is using it. I've done this, I have done this little exercise all over the world. I've done it in Asia, I've done it all over Latin America. A few months ago I was in South Africa, I've done it in Europe, I've done it all over the US, and there are no cultural differences, which is not that surprising because we're all wired, biologically wired the same way to learn. And sure enough, what is coming up on my screen here shows exactly the same result as the rest of the world. I'll project it in just a second. So take a minute to enter the circumstances that led you to become that skill. Okay, well, in the interest of time, I'm going to stop delivery here and show it on the screens of the people who have devices. And as you can tell, you see a word cloud, basically, where the size of the word tells you the frequency. And the one that stands out, we already heard that in the first keynote, is practice. It's not only violinists that need to practice, or mathematicians, or teachers, students in general. We learn by practicing. Now look at that list. Because wherever I do this on the world, the result is the same, and the point is not to point out that practice is the #1 choice. There's something else rather peculiar about that list. Who sees it? What is it? Look at the list on your screen. What is it? Shout it out because I can't hear it. The others, but which others? Maybe we should not so much look at what is on the list, but what is missing from the list. Teachers. Class or lecture or teachers, it's all missing. And how do we teach? This is how we teach. In fact, this is a picture of me teaching my introductory physics class for pre-medical students, a class that none of my colleagues wants to teach. This is a very old picture. It was taken BC, before computers. You see, I'm still using an overhead projector. So right off the bat here, we see that we have something peculiar going on. You all admitted that the skill that is really important in your life, you did learn it by practicing, not by sitting in a classroom or by lecturing. So this is what I'd like to do in the next half hour. I'd like to talk a little bit about education. What is it that we mean with that word? And next, I'd like to talk about peer instruction, which is a pedagogy. Thank you, Kirsty, for bringing out the importance of pedagogy as opposed to technology, that I developed after discovering that in spite of getting really high ratings for my teaching, both by students and by colleagues, my students were learning next to nothing. Well, that was a pretty disheartening discovery, and I completely revised my approach to teaching, which I'll be presenting in the second part of my talk. And lastly, since we're in an academic setting here, there'll be a test, right? So you better pay attention. Otherwise, you'll be in trouble at the end of my presentation. So let's start by talking about education. And given the fact that all over the globe we use the same types of learning spaces, the same type of lectures to teach, a logical question to ask is, what is it that happens in a lecture? Right? So let's take this picture again of me teaching there. Incidentally, why did I teach that way? I taught that way because I never even asked myself, how do people learn? How should one teach? I simply did to my students what my professors had done to me, projecting my own experiences onto the world around me. So I would like you, and you'll have to speak out loudly for me to hear it in front, I would like you to give me a description of the process here in 1 or 2 words, and ideally one of those 2 words is a verb, and the 2 verbs I do not want to hear are teaching and learning. So yell it out.
Construction.
Okay, construction.
Transmitting information.
Transmitting information. Let's hear some more. Listening, empowering. Did you say sleeping? My students are not sleeping. But actually, when you see those data that I will show in my workshop, you might actually be thinking that they're sleeping, and you're probably right. They're in a deeper state of neural inactivity than when they're in their beds. But interestingly, I recently came across a quote by the French writer Albert Camus, who said, "Some people talk in their sleep. Lecturers talk while other people are sleeping." I think that the one gentleman there who said transmitting information, however, said exactly the right thing. Most of our lectures, most of our classes focus on the transmitting of information. And you know what? My students had actually rubbed that in my face very early in my teaching career, and I had ignored it. You see, when I started teaching this class, I assigned a book to the students, which they all bought, and then I used another book, a different book, one that was out of print, to prepare my lecture notes from. This way, I wasn't just regurgitating the book to my students. And because my notes from which I was lecturing, by either projecting them on the overhead projector or writing them on the board, were different from the book, I handed out copies of my notes at the end of each class to my students. You know what the unexpected result was? The unexpected result was that on the end of semester evaluation, a handful of students wrote, "Professor Mazur is lecturing straight from his lecture notes." Hello, what was I supposed to do? Develop another set of lecture notes to lecture from that was different from the lecture notes I handed out to them? I mean, these ungrateful students, I was offended. But you know, they had a point. I was lecturing from my lecture notes. And if they had read the book, they would have seen that the book was not that different from my lecture notes. Now, that leads to the question, is that what education is? Is education just the transmittal of information? I would actually like to get your view on that. I projected a question here. 1, or A, yes, education is just the transfer of information. B, it's more than just the transfer of information. So I see the answers coming in rapidly. That's good. And we're fairly unanimous. There are just, right now, only 2 poor souls in the audience, I pity them, who are convinced that education is just the transfer of information. Let me show you the distribution. I'll put it on your device. So, what would be the logical thing to do if education was just the transfer of information? What should we all do? Get robots, yeah, or actors maybe. And in a sense, some of that is already happening. Not the robots, but what I have in mind. Videotape the best possible teachers, the best possible lectures, and put it online. One in English, one in British English, one in UK English, in US English, one in Spanish, one in Chinese. Every maybe 10 years you need to update it because clothing changes. But what would you lose? What would you lose by doing that?
Interaction.
Interaction. But how much interaction do we really have? Look how hard I have to work to get you to interact. Right? How much interaction do we have? Right? I mean, I often observe teachers, and they teach, and then they stop and say, does anybody have a question? Anybody? And you know how it is, right? The students look down because they don't want to make eye contact. And if you wait long enough that it becomes uncomfortable, it's always the same student in the front row who reluctantly raises his or her hand. So I don't think we'd lose much interaction. But we'd gain a lot. Students could watch the lectures whenever they want. They don't have to be in 1-hour block. They could be in 7-minute blocks or, you know, by concepts or subjects. But there's something else. You could actually think. Have you ever had a student in your class raising his hand and say, Professor, could you please be quiet for 5 minutes? I need to think. This never happened in my classroom. But you know, when you're listening to somebody, I don't know if you paid attention in other talks, do that. It's very hard to think. There's no opportunity to think because your brain is held hostage by the presenter. If you stop to think and dream, you lose track of what is being said. We're very poor multitaskers. So that's one advantage. The other one is you could rewind and listen again. And you could do it independently of the other students in the class. Or you could call up a friend and say, hey, do you understand what Professor Mazur says at 8 minutes and 21 seconds? So there are a lot of advantages. But, of course, and I'm happy we agree on that, 99% of you is convinced that there's more to education than just the transmittal of information. So now, to those 99, I have a question. What is it that is missing? What do you need in addition to the transfer of information? Challenge? Relationships? Personality? Feedback? Hey, we just did an exercise at the beginning of my keynote here. What was the result of that? Practice, of course. You know, and the learner has to do something with that information. It's not just that we open our skull, put the information in, and that's it. You need to connect it to your experiences. You need to build models. You need to apply, to be able to apply the knowledge embedded in that information into a new situation. I think the true hallmark of education is being able to take what you've learned and apply it in a new context. That is what real learning is. But so much of education is simply the professor delivering information to the students, then you wait 1 or 2 months, and the students basically regurgitate the same information back on the assessment to the instructor. I wish we had more time to talk about assessment. I'll bring it in my workshop, because I think assessment is the silent killer of educational innovation. And unless we rethink our approach to assessment, it's going to be very difficult to make any meaningful change to our approach to education. Most students don't study to learn. No, they study for the test. They study to pass the exam. So it's the exam, the assessment, that drives the study habits. And as long as our assessment basically simply asks for information that is regurgitated back, we're never going to produce students who can actually do meaningful skills. Okay, so what is the result of this? And I wish I could show some data, but if you go to YouTube, you can see a talk by me with the title Confessions of a Converted Lecturer, where I actually show the data that I obtained in my classroom. And in spite of my high end-of-semester evaluations, the students learned shockingly little. And these are Harvard students. They're a very select group of students. Lack of learning and lack of retention. The famous American psychologist Skinner once said, "Education is what is left after all that is learned is forgotten." And there's a deep truth to that, a sad truth in a sense, right? I think that most of what we at this current stage in our career know were things that were learned after we got our diplomas, not before. Furthermore, there's not just lack of retention of content, but there's also lack of retention of students, especially in my own discipline or in related disciplines, STEM disciplines, science, technology, engineering, and mathematics. A lot more students express an interest in these fields, which are so important for society nowadays, than actually graduate. And many different societies around the globe do not have a sufficiently large pool of engineers to draw from. So these are very serious problems, and I wish I could show you some data, but in the interest of showing you what I am going to show, I have to move forward, and you can see online the data if you're interested. So what is important is not the transfer of information, but the assimilation thereof, or in the words of Piaget, the accommodation, right? Adjusting the information to the mental models that are already present in your brain. Now, where did that happen for you? And for me, I've often asked myself, where did the aha moments occur? The, oh, no, I get it. Think about it for a moment. Did that happen while you were sitting in a room like this, listening to an instructor? Yes or no? No, I see most people shake no. No, it probably happened outside of the classroom. So if we think of education as a two-step process, one, transfer of information, because, look, we need transfer of information, right? No transfer of information, no education at all. But then the second step, assimilation of that information, and we ask ourselves, which of those two steps is the hardest step, the most elusive step? I think we would all agree it's step number 2, not step number 1. In the traditional approach to teaching, all of the emphasis is on the transfer of information, which takes place in the class. And the assimilation, the making sense, is left to the student on his or her own outside of class. And that's what we should really focus on. So 22 years ago, when I discovered how ineffective my standard approach to teaching was, I decided to invert this and to put all of the emphasis on the second part, leaving the first part to the students outside of the class. And in class, developing activities that help my students make sense of the information. Now, there's a lot of talk and discussion of the out-of-class component. How do we take the information and transfer it to the students out of the class, as if this is a new problem? Of course, the biggest invention in information technology solved that. And I'm not talking about the computer, I'm talking about the book. Gutenberg, 500 years ago, already developed something, a technique, to disseminate information outside of the classroom. And now with the internet and video and YouTube and so on, there are many more approaches. Most of them, however, are simply old wine into new bottles. People take a lecture, film it, put it online. To me, that's not the interesting part. The interesting part is what happens inside the class. So I now ask my students to read before coming to class, or to watch a video of a lecture that I've given before, or to do some other kind of activity. And I prime them by asking some questions. And then in class, I teach not by telling, but I teach by questioning. Nothing new there, right? Because Socrates, 2,000 years ago, already said, we should teach by questioning, not by telling. So I walk into the classroom, I talk a few minutes, and then I ask a question. And I give the students time to think. I'm silent, the other students are silent, they can think. After they thought for a while, I poll their answers. Initially it was multiple choice question, now with learning catalytics I can use any type of questions, including graphical questions. Or, you know, I could show them a painting and ask them to identify people. If you're interested in how that technology works, that will be later this afternoon. After I've polled them, I tell them, now turn to your neighbor, a neighbor who has a different answer, and try to convince that neighbor of your answer. The first time I did it because I tried to explain a problem in 2 different ways for 10 minutes. And the students were so confused that they were unable to articulate a coherent question. You know how it is, right? If you're really confused about something, it's hard to pinpoint what is the cause of that confusion. And in a moment of despair, I told my students, why don't you discuss it with each other? And something happened that I had never seen in my classroom. You know, and I have about 200 students in my classroom. The whole classroom erupted in chaos. They forgot about me in front of the classroom. I could have walked away, they wouldn't even have noticed it. What's more, in just 2 minutes, they figured it out. I had for 10 minutes unsuccessfully tried to explain it, and in 2 minutes they figured it out. I had trouble understanding that at first. But imagine you have 2 students sitting next to each other, Mary and John. Mary has the right answer because she understands it. John does not. On average, Mary is more likely to convince John than the other way around. But, and this is the most important point, Mary is more likely to convince John than Professor Mazur in front of the class. Why? Because she has only recently learned it. She still knows what the difficulties are that John has. Whereas Professor Mazur learned it such a long time ago, to him it is so clear that he no longer understands the difficulties that a beginning learner has. We heard a moment ago how the best math teachers are probably the worst teachers. The best mathematicians, pardon me, are the worst math teachers. You know, in a sense, it's what my colleague Steven Pinker calls the curse of knowledge. The better you know something, the harder it becomes to understand what the difficulties are that the beginning learner has. If you have the students parallel task, then, you know, they can address each other's difficulties much more quickly. I've done that approach now for 20 years. So basically, I poll them again, and typically the number of correct responses goes up dramatically. Then I wrap up with an explanation, which can either be my explanation or I can ask the students to provide their point of view, and the cycle repeats until class time is over. And the important part, of course, is that discussion, because that's where the learning takes place in the classroom. Misconceptions get addressed. Students can put their problems in their own terms and solve them in their own terms, not mine. Let me show you a little video clip of how this works in practice. So we have a rectangular Don't worry about the question. Uniform magnetic field in the direction indicated by these arrows. So the question is, what are the magnetic forces on the 4 different sides of this loop? So take a minute to think about this and then enter your answers. So they're thinking, it's quiet, they can actually think. Please enter your answers. This is when we still use clickers, which started in my classroom. Disagreement clearly here. So turn to your neighbor and see if you can convince one another of the correct choice.
Right. It goes out, the tongue goes in, so it gets to the back.
Ah, the aha moment there. Initially we had sort of an even split. And now we have an absolutely overwhelming majority for choice number 2. So students do not see the initial distribution, they only see the second one, right? That's not quite clear from that little video clip. Okay, so before we try it, what is special about this? One is it's active, not passive. There's no way you can sit as quietly as you sit there right now. I'm still going to try to get you a little bit more active here, right? Because every few minutes your neighbor will start talking to you. Sleeping in my classes is totally out of the question. Believe it or not, some students actually complain about that. They'd rather be sleeping. Secondly, there's a two-way flow of information, not only from me to the students, but there's information coming back. Lastly, there is continuous formative assessment. Students can stick out their neck. It's no problem if they get it wrong in class. There's no penalty for it. And if they're still among the 10 or 15% who gets it wrong after discussion, they've gotten feedback on their learning. Continuously, it's not just one isolated question, it's one after another. So that's a very different atmosphere than before. So do you want to try it? Good. Okay, now you're waking up. Okay, good, very good. So in your registration packet, there was a piece of paper that had a little explanation about thermal expansion. Did you all read that? I'm joking, I'm joking. You know, because, you know, flipped classroom, you need to be prepared before there's a question. I cannot just ask a question out of the blue. But, you know, that means that I'll have to give you a little lecture about thermal expansion. I'm actually quite happy you're providing me the opportunity to do that because I actually miss lecturing, you know, since I never lecture in my classes anymore. So thermal expansion, as you may know, metal, most solids, but metals in particular, expand when they get warmer and contract when they get colder. So that's very important in engineering. As you can see, this is a railroad in India where the tracks, the segments of the rail, the sections of the rail were laid too close together, so there was no room for expansion. The rail buckles, the train derails. Same in steel beam buildings. You have to take into account the expansion of the metals. The reason that metals expand is that metals, like any other material, are made out of atoms, and atoms get further away from each other when the temperature goes up. So this is a cold metal, and this is a hot metal. Cold, hot. You're smiling, but it's true. Now, you may wonder, this is actually the only thing I'm going to test, but you may wonder, why are they getting further away from each other? Well, the reason is that what we call temperature has to do with the thermal motion of atoms. Atoms don't sit still, they shake back and forth, and the amplitude of that motion is what we call temperature. So this is these are cold atoms, these are hot atoms. Right? As you can imagine, if you move over a bigger amplitude, you need more space. So as they need more space, they move apart. It's an internal form of energy, if you want. Questions, anybody? I knew I gave very clear lectures. Look, it's not just those 9, right? Cold, hot. It's all of them, all millions of billions of atoms inside the material. No questions? Look, I'm not going to... See, one of the things I could do is make the screen black and then ask you the question, when metals heat up, they expand because the atoms A get closer together. B, stay the same distance apart. C, get further apart. But that would be simply me giving information to you and you regurgitating that same information back to me. I'm going to see if you have really understood this picture of atoms getting further apart and can transfer it to a new context. Are you ready? Yeah? No questions? Wow. Okay. So, here's the question. Consider a rectangular metal plate with a circular hole in it. Okay, and there's not going to be any talking, right? You first work on it individually. If you start talking, I run to you with the microphone, and you're going to have to talk in front of everybody. All right? All right. When the plate is uniformly heated, the diameter of the hole, 1, increases. 2, stays the same. 3, decreases. What? 20 people have already answered. Have you thought about this? Please, think. Think about atoms getting further away from one another, okay? So take your time and then enter your answer. No, remember what I said. I have a microphone here. I'll run to you. Here, the holds for you too here in the front. Okay. A lot of people have been messaging me here. What is your definition of education? Hello, somebody wrote. Okay, so let me tell you a little bit what we're going to do next. What I'm going to ask you to do, I'm going to give you a little bit more time in just a second, but I want you to turn to a neighbor and first say which answer you've given. And if your neighbor has given the same, no, stop, wait a second, you get a chance in just a second. If your neighbor gave the same answer, you say, thank you very much, and you turn, to your other side, or front, or back. And if everybody around you has the same answer, you get up and walk around in the lecture hall. It's no problem. But you have to talk to somebody who has a different answer. Once you've convinced that person, or that person has convinced you, don't just sit there still, because I'm going to come right at you, right? Continue the game. Try to convince somebody else. So go ahead, find somebody else, and start discussing it. Now look at that. Now you're engaged. You got all fired up. Look, and there's still some people sitting there. Hello? I'm sure that by now, most of you have forgotten that I'm not here to talk about metal plates. You know, I'm here to talk about education. The answer to this question doesn't matter. It doesn't matter. I'm sure that if I walked away right now, out of this classroom, many of you would come running after me, asking me what the answer to this question is. Well, you need to answer the question again before I tell you the answer. Okay, only about 41%. And I realize this is out of context. I've not given you enough time to really debate and think. And so I have only about 50% of the answers in. So, you know, before I tell you the answer, because I'm going to keep you in suspense a little bit longer here, let's analyze what happened here. What happened here was that, one, you made a commitment, right? I had you press on a button, or, you know, with a clicker, or in this case, press on a button on the screen, or maybe you mentally wrote down an answer or committed to an answer, but you made a commitment. After you made a commitment, you had to externalize your answer. You turned to a neighbor and you said, I chose because blah, blah, blah. And the discussion turned from answer or fact to reasoning. Right? Your discussion, you actually got beyond the answer or just the fact. But most importantly, you became emotionally invested. You're all dying to know what the answer is. I mean, imagine I'd just given a lecture, the little lecture I'd given on the expansion, and I said, if we take a metal plate with a circular hole in it, and we put the plate in the oven, and we take it out, the diameter of the hole will, I'm going to keep you in suspense a little bit longer, but you know, you would not have had this level of engagement. You'd be sitting, maybe taking notes, but there would not have been this eagerness to wanting to understand it. Well, you know, in spite of the fact that my lecture was brilliantly clear and nobody had a question, only 20% got the question right the first time around. And you know, the method doesn't work when it's just 20%, because that means out of every 5 people, the one lonely person who got it right is, you know, outnumbered 4-to-1. Typically, the questions that you ask have to have a minimum of 35% correct, and a maximum of 70, right? Because if more than 70, look, they're still sitting there talking about that. I'll tell you in a second, don't worry, okay? It won't be on your assessment, trust me. You know, so basically, if it's more than 70% to get it right, it doesn't make much sense to have them talk to each other. If less than 30% get it right, it doesn't make much sense to have them talk to each other, which was this case here, right? Because the students can't help one another. And in fact, that's clear from this distribution. The correct answer is answer number, God, look at the suspense. I mean, come on, this is just a metal hole with a metal plate with a hole in it. It's number 1. Oh. Now look at that, you're again. I'm sure you have again forgotten that I'm here to talk about education, not about thermal expansion. Listen, I don't want to be responsible for you lying in bed tonight thinking, imagine you have a jar of marmalade in the refrigerator. You can't take off the lid. The lid is a ring with a metal plate on top. What do? You run the metal lid under hot water so that the ring expands. You say, that's unfair. It's a ring. This was a plate. Okay, imagine we take a metal plate without a hole in it. We draw a circle on it. Now we put the plate with the circle in the oven. It expands. What happened to the diameter of the circle? Has to get bigger, right? Everything bigger. It scales up, so the circle will get bigger too. You say, that's unfair. There's no hole. If there was a hole, then the atoms would expand into the hole. Well, let's think about that for a moment. Imagine the atoms at the edge of the hole. We form a big circle. We go outside, form a huge circle. We are the atoms at the edge of the hole. Now we walk in towards the center of the circle. What just happened to the distance between us? Got smaller, can't get smaller. Remember, the neighbor is shaking more. The only way to make the distance between us larger is to move out. You won't forget this. Now, again, you're probably still completely engaged thinking about plates, but we're here to talk about education. So let's briefly get back to peer instruction. And again, unfortunately, I cannot show you data. But in 20 years of use, many people have shown much larger learning gains and much better retention of students. And again, I have to refer you to what's online to see the actual data. So in conclusion, education is not just about transferring information, which is what we mostly focus on, or getting students to do what we do. I want my students to stand on my shoulders, to solve the problems I cannot solve. We want the next generation of students to solve the problems that this generation, we have not yet solved. And teaching by telling will never get them to that spot. I think active participation is an absolute must. If you're interested in more information, that's the URL of my website. You don't need to write it down. Just go to Google, enter my last name, M-A-Z-U-R, and then hit this I'm feeling lucky button, and you'll have a copy of my presentation. Incidentally, I've taken completely care of this comment by students. Professor Mazur is teaching straight from his lecture notes. You know what they say now? Now they write down, Professor Mazur is not teaching us anything. We have to learn it all ourselves.